everything will go good. So hey guys, welcome to High Entropy. And yesterday, I want to say apology, or I just want to apologize. And the reason for that is yesterday I was streaming and I thought let me start another question, and suddenly power cut happened, and because of that I was like internet got stopped, and electricity and everything. Then I went out for dinner. I just waited for a few minutes and went out for dinner. That's the update about yesterday. But yeah, we were able to solve like one problem, and today the goal is like we need to solve another problems, and we need to jump. After that I was like internet. Oh, and what is this? And electricity and oh, I thought I went out why it is dinner. I just waited for a few minutes and went out for dinner. So if you are going to watch it yesterday, but yeah, we were able to solve like one problem, and today the goal is like so let me jump and let's solve the problem. And if you are watching for the first time, welcome to High Entropy, and we are on a mission to solve DSA and will fix or you can say I'm just learning and learning DSA to make better logical skill, and yeah, so that I can solve the DSA problems. So here I'm on a mission, and so far we have covered array and some part of binary search is pending. Other than that, like we have covered 4 sections out of 5, and now we need to start 5th section. So far everything is going good. Sometimes it becomes little hectic, but sometimes it's easy, and most of the time I get stuck when I have to debug the problems. I do not get what exactly the problem is happening, and then I take a lot of time. So that is also the scenario. Okay, this is a easy problem. Let's see if it's easy. Sometimes like the problem is easy, but it become difficult when you are not able to you can say when you are not able to get the solution for it. So let me see if I have solved it before. No, so it's completely new for me. Okay, that's great. So given non-empty grid matrix consists of only zeros and ones. Okay, consists of only zeros and ones, where all the rows are sorted in ascending order. Find the index of the row with maximum number of ones. 1 minute, bro. Given a non-empty grid matrix consists of only zeros and ones, where all the rows are sorted. All the rows are sorted. That means ones will be at the end, zeros will be at the starting. Okay. In ascending order. Okay. Find the index of the row with the maximum number of ones. If two rows have the same number of ones, consider the one with smaller index. If number okay, great. If number 1 exists in the matrix, return -1. Oh, if no one exists in the matrix, return -1. Okay, got it. Just it's like a thought process. If it will work, everything will go quickly. We will be able to solve it quickly. But if I won't be able to, let me note it down first. I won't use the array and add this 1 1 1 and 0 0 1 and 0 0 0. And the second example is 0 0 and 0 0. Woohoo. So the size will be m into n. Now let me see the constraints first. N is nothing but matrix of mat dot length, m mat of I dot length, and nm can be between. So it's like a smaller number. The numbers are smaller. Even you can use naive approach would be like you are not using binary search, and you can simply solve it using just calculate the number of ones in this one. So it will take order of m into n. So this is one approach, but we don't want to use that. And another approach is like we can use binary search at each, yeah, binary search. Great. Now we can say what I'm thinking. Okay, I just need to put it down so that I can, when I'm writing, I can, you can see my face. I don't know. I'm I'm like Modi, Mr. Modi. Okay, so it's like something like this. Hmm. And first thing is like you can use this order of m and calculate for each one, each row, and then whatever the max index, just store it somewhere, keep -1, and then just start from it, top to bottom. But that is order of m. And second approach is like you can use binary search at each. So okay, so like here just what needs to be done. Low will be basically the zeroth index, and high will be nothing but what, let's call it array. So you can consider array of 0 and dot length, or even you can say -1. It's better, you don't need to take care of -1 and all, you can consider it directly. And now you just need to calculate mid. If mid is 1, okay, that means you are in the right direction and you have to move to the left direction. Okay, so what you will do, just you will say mid is 1 and we need to find the 0, first 0. Okay, or last 0, not first 0, last 0. So you can't say like it will be result, so you have to, if mid equals to 1, okay, let me say it like this, if mid equals to 0, so it could be result, right? So you can say result equals to mid. And now we need to find another or higher the index of 0, boundary index. You can say like if there is 0 0 1 1, so this you need to find this index of this one. Okay, great, this one. So yeah, that's why like you can say, bro, it will be something like this, result will be mid, and earlier it was -1, right? Result will be initially -1 because you don't know whether we will get or not, bro. But what if we are getting end? Okay, okay, we'll consider it. If we are getting the end, like we are reaching at the end, and if it is last one, then we'll consider like -1 only. Then the result, oh okay, low will be mid plus 1, else you can say the number that we are getting 1, so high equals to mid -1. I hope now it's working, but after some time, so that's why I changed to white paper today. I'm using new, you can say workbook, worksheet. Okay, so this is a condition, or this is the way to do this. But I'm just assuming, is it right approach to apply binary search is still, I mean just it's binary search, so can't we do, like if we going to do this, you are going to apply binary search at each level. It will be log of m rows n columns, log n into m. Can we optimize it? 0 0 1 1 1 1 0, no 1 1 0 1 1 1 1. Okay. I know right now what I'm doing. I'm applying binary search at each row. But is it a good approach? Let's say it like this if it is. We got this too. Okay. What needs to be done? I need to return the index of row that contains maximum 1. One thing I can do, like here, just we need to check if mid, the index that we are getting so far bigger, if that index has to, so it will optimize little bit more, then you can say it can be possible. But if it is 0, then it won't be in the result mid index. And same we can check here. So you know what needs to be done, like whatever the mid that you are getting from the first array. I mean, yeah, still it's not going to help us. You can use it for another arrays, but before that you need somewhere mid. Bro. Think more. I know one thing I for sure I can do, like first try to find the mid in the first. Can we do something from the second onwards, like by row wise, column wise we can use binary search. But what about row? I learned somewhere like where the array is sorted in both direction, then you can apply binary search and find. No, bro, but that is different case. Think more, bro. Man. Zero, one. So we got this. We need to check in another one. Can we take the help of first one? Okay, if we got mid that is not -1, then definitely we need to check in next one, like if mid plus 1, mid minus 1 is then also problem is we will consider this one. No, it won't work. If you are hearing some noise background, some of my neighbors are playing old Hindi songs, 90s songs, I believe. Man, but let's ignore it, ignore them. How can I do this? So, if you know, like if there are more, I mean, it's like we are looking for something that is larger in this direction, bigger and bigger in this direction. So if you want to go towards that direction, this that means can we use two binary search? Then it will be optimized, right? So let's say here we got a mid. Mm-hmm. Can we decide if we got some mid value here and if we are going to calculate the binary search for that, and if it is the number that we are, no, we cannot decide. It could be in right direction, it could be in left direction. Am I missing something? Zero 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 one one. Come on, man. 001. Let me see hint if I can get something from. Okay, 00011. And if we want to move is this in this direction, what is the solution for it? It should be bigger than this number. Can I use something like if it is something like this, what would be the case? Wait a minute. I mean, I'm just more concerned or what? I thought they will be having some other solution. Okay, wait a minute, bro. Come on, man. I'm still dumb. I was expecting something else. Like I thought maybe they have given two-dimensional array. What's wrong with me? Okay, let me do one thing. Let me create a function. Get index. So self, and here will be low. Okay, let's say matrix will going to pass matrix and index. Okay. Okay, low will be 0, high will be matrix of 0, minus 1. Great. So while low less than equals to high, okay, and let's say result equals to minus 1, so initially it's minus 1, while and mid will be nothing but low plus high by 2 if mat of, okay, let's use I know it's not necessary, but mat of I into mid equals to 0. That means it could be result could be mid, and result could be mid. And now we need to find out, we need to low will be mid plus 1, else high will be mid minus 1. Great, so far everything is going great. And at the end, if you like, it will be the case where everything is 0, so it will end up with at the last. So result will be the last 0, right? So if result equals to, that means what? You can say high. So that means, okay, let's call it instead of result bz, boundary is 0. Okay, no need to do anything. Okay, we can say return how many ones are there. So man, pz, so boundary 0, so total n is the basically high. 1 minute, let me do one thing. N equals to len of mat I don't want to calculate 2 times n minus 1. Okay, return. So total length is n minus, and result will be the last index n minus, and you can say 0. So you can say bz boundary 0 plus 1, that is number of zeros. And finally, bro, why are you taking so much time? for I in range len of mat of 0. No, mat of len of matrix, so it will give us the rows, number of rows, and here we can say result will be nothing but nothing but -1. Result will be 0. Okay, 0 means so far we don't have any max value, and you can say idx will be -1. Okay, and now just we need to do two things, like here just we need to say no get count, let's call it. What are you doing, man? I haven't solved it in the white paper, right? What you did, bro? So you can say cnd is nothing but get self dot get count, and you will pass matrix and I, that is nothing but, and if cnt greater than result. Okay, so that means we have a new result, and so result will be cnt and idx will be I. Okay, and finally return I. If we haven't got anything, that means return -1. I hope I covered I think I covered everything. What I did? Return I. Return idx. I think I haven't. I took all the corner questions. I'm hoping so. Oh, great. So it's pretty easy for a problem. Just we need to. So it will take the length of a number of rows into log n, number of column. So I thought maybe I took a lot of time, bro. I was expecting something different. I thought maybe they kept it in section 5. Then it will be some smart problem. I am just missing the cases, corner cases, you can say. Now I'm thinking like, shall I start attempting this problem up, and what if I won't be able? Okay, but no problem. So we have 1 hour of time, and we are going to attempt it. So here we are not to showcase something. Here we are to build something. Given a 2D array matrix, where search in a 2D matrix, I think I solved it somewhere in the past. If it is sorted in both directions, yeah, you can see it. But I forgot. Man, don't show me the solution. I don't want to see the solution. How about delete it, bro? Okay. So given a 2D array, when I solved it, I forgot it. Wait a minute. April 2025 to 2026. Really? Search in a 2D matrix? I'm just confused. Is it something like I solved it using the another approach? Maybe? Let's see. For the time being, let's forget about that. And let's focus on given a 2D array matrix where the elements of each row are sorted in non-decreasing order. That means all the elements are in increasing order. Okay, and the first element of a row is greater than the last element of previous row, if it exists. Okay, and an integer target determine if the target exists in the given matrix or not. So we can say the complete array is in a sorted order, just it is splitted into multiple rows instead of single array. Okay, great. So I think I solved it in the past, that's why it will be little easy for me. But I won't say it. I always do lot of mistakes. So my confidence is getting low. 5, 6, 7, 8. And the third one is 19 and 11, 12. Bro, moral should always be high, then only you will be able to attempt the things, otherwise it will be like, oh god. And I have 1, 2, 4, 6, 7, 8. Actually I am planning to order food today, I don't know, but I want to go out first thing. I'm looking like a zombie or what? So target is nothing but 78, and here target is nothing but 8. Good. So you know what, not Uno, you know what needs to be done. First thing, it is sorted, and I'll tell you how. Okay, what is if not found, then return minus. Okay, just need to find out and return that. True. If it is found, if it is not found, then return -1. True or false, basically. So it's easy problem, and I can assure you. But let me try to articulate in the proper way. So what exactly the problem is saying? So basically, it is saying like the last element of the previous row will be, okay, the first element of the next row will be greater than the last element of, greater than, or it could be equals to the, and the first element of a row is greater than the last element of the previous row if it exists. Okay. Okay, is there any other input like unique or what? No, not unique. So no problem. Okay, so first element of the second row or next first element of a row will be greater than the last element of previous row. So you can say it will be something like this. This is first, and now this is, and now this is, no. Now this is. So if you will say like it is something like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We can assume like this. So total indexes, let's count what will be the index of, if we it will be the single flattened row. Instead of multi-dimensional, it will be single dimension. Then the first will be 0. It will be 0, 0, and it will be 0. You can say this number. This is nothing but m -1 you can say, and n -1. M is number of rows. So you can say it will be something like, if it is 0, the first index will be 0, and the last index will be m into n. So total number of elements are m into n. So m into n -1. These many elements are there. So you can say simply take total number of elements, and if you are going to flat them, so you can say m into whatever the length is. For example, if the length of array is n, then the number of the last index of element will be the last element, index of last element will be n -1. Similarly, if there are total number of element m into n, then last index will be m into n -1. And now just apply the binary search, but whatever the mid that you are getting, it won't be sufficient, so you need to check what. Hmm? We need to check row and column from it. So for that you can say if there are n columns, n calls and m rows. So okay, so what you will do? Just do one thing. Basically, mid by number of calls. So calls, if you will divide it, you will get something like coefficient you will get, and that coefficient will you tell you if it is 0. I mean, if suppose there are less than 0, if you are getting 0, that means it is first row. And then column you can get it. How you will get column through if that is the case? So row will be nothing but mid divide by column, mid by n, you can say, not column. And now you wanted to get row. I'll tell you that also. I don't know if there is another option, but so you got the row. I mean where it belongs, and you know the index mid, and you know so you can say row minus 1 into column. If row not equals to 0, then you can say like, okay, for example, if it is whatever the number it will be, so it will be like you are just subtracting the number and you will get the column. And now based on this, whatever the value, if it is greater, okay, now if okay, now how I'll tell you, no, what I'll tell you, mid plus 1, if number is greater than this number, or if it is lesser than this, the same apply, just apply. So we'll do that. Now let me note down let me write the algorithm first. I will solve it later. I mean low will be 0, high will be, okay, first let me note down m and n we have given. M into n minus 1, this will be the, okay, while low less than equals to high, so mid will be low plus high. Oh man, what is this? It started lagging again. You got the mid. Now just calculate row and column, and so that you can check the value at the mid, what exactly value is there, and if it's greater. So row will be mid pi by mid by the value, you can say mid by m is number of rows. No, I'm doing n calls, right? And based on row, if r not equals to, if r equals to 0, just thinking like, can I do it without applying this condition and I can get the remainder whatever we are getting? I think so, I can do that. Oh, let's leave it. No, no, I mean, yeah, I think we can do that, but also then also we need to add condition. So I'll do this only. If r equals to 0, then call will be nothing but the mid value, mid will be the column. Okay, I mean 0, 0, 1, 1, 2, 2. Else it will be something like whatever the index that you are getting, that will be the. Hey, am I missing something? Mid can be 0. Mid into minus r into God, a row number. So r minus 1. Oh, just thinking. Suppose it's like n minus 1. I'm just little worried about the corner cases. I feel like I'm just missing some piece here. So m into n minus 1. That's why I'm just debugging it before writing the code. I just want clarification from this problem. Low is 0, high is m into n minus 1. Okay, that's great. Low less than high, mid, whatever the mid value that will get. So mid will range between 0 to m into n minus 1. This will be the value. Okay, now row we are calculating when if it is m into n minus 1, and now we are dividing it by n. So it will be something like you are going to get n minus 1 remainder. Okay, so remainder will be, okay, no, r will be m minus 1, because m for m minus 1 rows it will be perfectly divisible by this. Okay, and last row, for the last row it will be something like, okay, you got m minus 1 and I'm expecting last number, so column will be mid is m into n minus 1 minus, hey, what are you are mad? mn m into n minus 1 minus m into n and plus n, so it will be cancelled out, n minus 1, so the last element, last index. But if you notice, when I'm getting remainder, it is also n minus 1. So I don't think I need to take this, I can take the remainder only. So if remainder is between like 0 to n minus 1, it will be considered in the same column, but once it will reach n, then it will turn into new. Okay, bro, I don't need to take care of all the bullshit row 0 and all. I need mathematics. I need to learn mathematics. I believe. Sure. 8:58 it's only. Really? Bro, today I think watch is with me. Clock is in sync with me. I don't know. Like every day I lose the track of time, but today I don't know. It feels like I'm just so low. Let's 0 and okay. Let me first calculate the m. M is nothing but len of matrix, and n will be len of mat of 0. Okay. Low will be 0, high will be you can say m into n minus 1, and let's start binary search while low less than equals to high. Okay, so mid will be nothing but low plus high pi by 2, and now we have mid value and we need to check. Oh, I think I haven't wrote the complete code or what. No problem. Okay, let's do one thing. Row. Let's say row. Row will be nothing but mid pi by you can say n number of columns. Okay, you will get row. Column will be mid percentage by n. If there is no remainder, it's full divisible, that means 0th index. So we got row, we got column, and now just we need to check if row, if mid, no, if array of, what is the value, matrix of row and column is equals to what, the target. Hey bro, come on, don't try to jump here and there. Target, then return true. Okay, else if mat of row and column is less than what we are looking for, target, then we need to move forward. So low will be mid plus 1, else high will be mid minus 1, and finally just return false. That means we are not able to find. Perfect. Oh, perfect. It's not a hard problem. I mean, I don't know, it might be because I solved it so many times, that's why. Okay, now I'm just confused. Shall I jump into another problem? But I don't want to be greedy. Two problems if I solve today, I just don't want to put more burden on me. Do you know, all the records being made only when you are putting extra pressure. So let me okay, search in a 2D matrix part 2. What is time right now? 9:02. Okay, maybe let's leave it. We'll solve it tomorrow. Again, no problem. Thank you. Bye bye, and keep practicing. Bye bye.